Hello everyone. Today let's solve the problem square year. Right. So this was asked in Codeforces round 1027 div 3. Right. So you can just go through the question. This is very simple question, man. You can just go through the question, you'll understand. So I'll just summarize the question so that it will be easier for us to solve the problem. Right. So what the question states here, we are given a, just give me a second, 1 second, just 1 second. Yeah, we are given a 4-digit year S. We have been given a 4-digit year S, right? So S, whatever we have given string S is nothing but a 4-digit year. Suppose, for example, you consider this one, 1111. So if they have given 1111, this 4-digit is nothing but the year, right? So just keep this in mind. We have been given a string S which consists of the 4-digit, nothing but the year. We have to check if it can be expressed as a plus b whole square. We have to check whether this number can be represented by a plus b whole square. So that's what we need to do. Again, I'm telling what we need to do here. We have to check if it can be expressed as a plus b whole square, where a and b are non-negative integers. So a and b both are positive integers here, right? So both are positive integers, right? Positive integers. Just remember this one, right? So we have been given a 4-digit year S as a string. Check We have to check if it can be expressed as a plus b whole square, where a and b are non-negative integers or the positive integers, right? So in other words, we have to find the integer value of S, whether it is a perfect square or not. If yes, we have to print a and b such that a plus b equals square root of S, right? A plus b equals square root of S. If it forms a perfect square, then we have to print a and b such that 0 a plus b equals square root of S, right? And also we have to keep in mind that a comma b is always greater than or equal to 0. Non-negative integers they have clearly mentioned, right? So a comma b is always greater than or equal to 0. If it is not possible, if it doesn't form a perfect square, then we have to return -1. This is also one edge case, right? So just keep these things in the mind. Very simple question, right? Very simple question. So I hope the question part is completely clear. I hope the question part is completely clear. Now let's discuss the approach first. Let's come to the output here. We have been given 5 inputs here, right? So 5 inputs, 5 represents that we have 5 inputs. So this one, 0001, 1001, these are the 4-digit integers, nothing but the years, which represents the years in the form of string. S equals 0001, S equals 1001, S equals 1000, S equals 4900, and S equals 2025. 5 inputs we have been given here. For this one, it can form a perfect square of 0 and 1. It can form a perfect square of 0 and 1. For the second one and third one, it is not possible, so they have given -1. And for the third one, we can form a perfect square of 34 and 36. For the fifth one, we can form a perfect square of 20 and 25. So that's what they have given. Very simple to understand, right? So I hope this part is completely clear. Question part is completely clear, right? Along with the input, they have given us wonderful examples just for the sake of understanding. They have given wonderful examples just for the sake of understanding. I hope the this one question part is completely clear, right? First, what shall we do? Let's discuss the approach. First, let's discuss the approach followed by the complexities, and then let's write the code. First, let's discuss the approach followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. Here, we have considered the same first example. First input was 0001, right? So the first input or the first example that they had given was 0001, and the output that we need to get here is 01, means square of 0 plus 1, right? So we have to check whether we get the desired output or not accordingly with the approach. First thing that I have to say here is we will be making use of the binary search. We'll be making use of the approach binary search to solve this particular problem, right? To solve this particular problem. So let's move on with the step-by-step explanation here, right? So the same input we are considering here, 0001. So first what we'll do, we'll convert the string to the integer 1. We'll convert the string to the integer 1. So this is fine. After successfully converting the string 0001 to integer 1, we will be making use of the binary search to find 1 is a perfect square or not, right? 1 is a perfect square or not. So what we will do, we will try the middle values until mid into mid equals 1. So we will try all the middle values until mid into mid equals 1, right? So this part is important actually. I hope this is clear. This is clear, simple one, right? So when mid equals 1 works, square root will be quite obviously 1, because we have the integer 1, right? So when mid equals 1 works, square root will be quite obviously 1, right? I hope this part is clear, right? So since 1, how can we write here? Square root is quite obviously 1. So here, when we consider the integer 1, this has to be represented by a plus b whole square, in the output, right? So 1 can be represented in this format: 0 plus 1 whole square, 0 plus 1 whole square, nothing but we will get 1 square here, nothing but 1 square is nothing but 1, right? So for this one, so here we have to represent the output or return the output of a and b, right? We have to represent the or return the output a and b, which forms the integer basically. So 0001, we converted that one to the integer. So we were given in the binary format, we are converting to the integer, it becomes 1. Then we for the 1 to work means, if we have to represent that one in the form of a plus b whole square, then we have to uh, get the this one square root should be quite obviously 1 itself, right? So now what will lead us to the 1 basically? What will lead us to the 1? Basically 0 plus 1 whole square will lead us to the output 1, right? 0 plus 1 square, 0 plus 1 whole square will lead us to the output 1. So this can be represented in this format. This one will be a and this one will be b, right? This one will be a and this one will be b, right? So here in this case, we need to return this 0 and 1 as output. We are returning this 0 and 1 as output. So here in this case, 0 and 1, we got 0 and 1 as output, right? For the particular this one input. First example we have considered here. So the output that we got here is 0 1. So I insist you to try out with the fourth and fifth examples. For the second and third examples, you will get -1. So you can just try it out for that one as well. You will not get any a plus b whole square cannot be formed with the input that they have given, right? So we cannot in that case, if we don't get the a plus b that forms the square root, so then we have to return this one, what do we call, -1. So I insist you to try out with the fourth or the fifth example so that you understand the question clearly. So I have shown you for the first example here in this case, right? So now we got the output 0 1. So I insist you to try out with the fourth or the fifth example so that you understand the question clearly, right? So just please try it out with the fourth or fifth example, right? So now we have got the output 0 1, which is equivalent to the output that they have given for the example 1 in the question. So our approach works absolutely correct in this case. And one more thing before moving into the complexities, if square root is not found, then we have to return -1. So this is given in the question as well. I just wanted to write this one, right? Don't forget this one. We usually forget, right? So if square root is not found, then we have to output -1 in that case. So here in this case, we can square root is found, right? 0 plus 1 square forms 1 basically. Square root of 1 so is nothing but 0 plus 1 square forms the square root 1, square root of 1 itself, right? So here in this case, we have got the output 0 1, which is equivalent to the output that they have given for the first example in the question, right? So I hope this part is completely clear. If square root was not found in that case, if square root not found in that case, we have to output -1. Just keep this in mind as well. So now, as we are completely familiar with the approach, let's discuss the complexities. So the time complexity for the code that we'll be writing in the future would be big of n. So why it would be big of n here? We are going with a binary search first of all, right? So we are going with a binary search here. The time complexity would be big of logarithmic n per test case, because we are maintaining the binary search for the square root. We will be maintaining the binary search for the square root. This you will try, this you will understand when we write the code, right? So the approach will be binary search for the square root. So for finding the square root. So here in this case, for square root, sorry, not for finding the square root, for square root. So here in this case, the time complexity would be big of logarithmic n, and the space complexity would be big of 1. When I say space complexity is big of n, because we'll not be making use of any extra space except the variables, while we are making use of the binary search. So overall, the time complexity would be big of logarithmic n, and the space complexity would be big of 1 for the code that we'll be writing in the future. Now we are completely familiar with the approach as well as the this one complexities. As we are completely familiar with the approach as well as the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. First, let's go with the we will be making use of the utilities. So let's do one thing. Let's import the util package. So I'll just go with util.star. So here in this case, let's go with the class main here. Anything, any class name you can give. I'll just give here class main. This is fine within the main class. So we'll be making use of the binary search method to find the square root of a number if it exists, right? So we have already discussed this one multiple times. We will be going with the binary search, as I said this one earlier, that we'll be making use of the binary search method basically to find the square root of a number if it exists. If it exists, if it doesn't exist, then we have to display -1, or we have to return -1, right? So let's implement the binary search method to find the square root of a number if it exists. So I'll just go with static int square root of, so within the parameters, so let's make use of the n here. This is fine. So within this, let's do one thing. Let's go with the left and right. So I'll just go with int left equals 0 and right equals last index, nothing but the n here, right? So here pure binary search, while left less than or equal to right. So what we'll do, we have to calculate mid first. So I'll just go with mid, m for mid here. This will be left plus right by 2. This is fine. Left plus right by 2 to calculate the mid. Basically the next one is we have to avoid the integer overflow, right? We have to avoid the integer overflow. So to avoid the integer overflow, let's convert this one to the long. So here in this case, I'll just go with long square root. This one, I can just whenever we are making use of the long, we have to go with L, right? Capital L. Here this one will be 1 into m into n, 1 L into m into n, basically, right? So to avoid the integer overflow, we are just making use of the this one long, or we are converting to long. I hope this part is clear. Next, if a perfect square exists, then we have to return its root, return the root, right? If a perfect square exists, then we have to return the root, nothing but here if square root equals n, if perfect square exists, then we have to return the root, nothing but here return m. We have to return m, right? So then we have to move to the right half, and then we have to move to the left half. Means here in this case, let's write the simple if condition. We are just performing the simple binary search here. If square root less than L, then L equals mid plus 1, and the next step is else we have to move to the left half, nothing but R equals mid minus 1, right? Equals mid minus 1, right? From the right, if you are moving, it will be right, this one mid minus 1, right? So from the left, it would be mid plus 1, pure binary search here. So if we do not find a perfect square, then we have to return -1. In the question they have strictly mentioned that one. So let's go with return -1 if we do not find a perfect square. I hope this part is completely clear. So this is it for the logic. This is it for the logic, right? So let's do one thing. This is just the input, basically input output part, right? So let me copy paste this one. So I'll just explain this one. So we are done with the logical part here. We are done with the logical part. So this is just related to the input output part. This is just related to the input output part except this one. So let me explain this one very quickly. So this is nothing but the line number 14, nothing but the fast input scanner, right? Fast input scanner. This is nothing but the number of test cases here. T equals sa dot next int, whatever I have given this one. So here sa dot next int, whatever I have given, y equals sa dot next int, this one we have to read the 4-digit year as an integer, right? So we have to read the integer. That is the reason we have made use of next int here, right? K equals square root of y, this one, k equals square root of y, whatever I have considered here, this one we are checking if it has an integer square root using the binary search. We are searching here in this case, we are checking, sorry, if it has an integer square root using the binary search. This is still the logical part. This one, what do we call, line number 21, basically. Just remember this one. K equals square root of y, whatever I have given here. We are checking if it has an integer square root using the binary search. So if it has, means if it has an integer square root, then what we'll do, we will output a equals 0. We will this one accordingly with the this one, line number 22. If it has the integer square root, if it has an integer square root, then what we'll do, we'll output a equals 0 and b equals k. We'll output a equals 0, b equals k, since a 0 plus k whole square equals y, since 0 plus k whole square equals y. Else what we'll do, we'll output minus 1. Else we'll output minus 1. So this is it for the input output part, right? So this is simple. This is simple. So I hope this part is completely clear. I hope the input output part is completely clear along with the logical part. Very simple, right? Pure binary search. So here in this case, let's try this one, whether this works or not with the, let's try with the inputs, whether this works or not. Let's check. So here, let me paste this one input and let me run this one. So yeah, we are getting all the outputs as 0, 1, 0, 1, 0, 1. Why? Yeah. Did I miss anything here? So here we are getting 0, 1 for every this one, right? So let's see what is wrong here. So here in the line number 9, I have missed something here. So I have not missed something. I have written wrong here. So basically, we are in the line number 9. What we are doing, we are just avoiding to avoid the integer overflow. We are converting to long, basically, right? So here this has to be 1L. Nothing but this indicates that L indicates that we are converting to long. Basically, this has to be M into M, right? M into M. Right, so this is not m into n. So here I had made a mistake. So let me run this one again. I hope this works now. Yeah, now this works correctly. Now this works correctly. So let's check what is the output that we need to get. Still this works wrong itself, right? So here we are getting 0, 1, minus 1, minus 1. This is fine. We have to get 34, 36, 20 and 25. 34, 26, 20 and 25. Instead we are getting 0, 70 and 0, 45. This is so this has to work, right? So let's see. Just give me a second here. So here actually 0 and 70 also works for the square. 0 and 70 also works as A and B for this one, 4900, I think, and also 20 and for the 20, 25, 20. Apart from 20 and 25, 0 and 45 also works. 0 and 25, a plus b whole square, 0 and 45 square also works along with the 20 and 25. Because when we this one sum up this one, you can clearly see here, this will be 20 plus 25 equals 45 itself. We are considering 0 and 45. This should also work, right? This should also work. We are considering 0 and 70. Here this, you sum up this one, 34, 44, 54, 64, 70. 34 plus 36, when you sum up it will lead to 70 itself. We can consider 0 and 70 as well, right? So both works, right? Don't get confused here, right? Both of them works. Any square root that has to lead to the output 2025 here, right? 2025 and 4900. So it is not that we have to go with 34 and 36 itself for the output and 20 and 25 itself. It has to lead to the output. Multiple outputs are there, right? We can go with the multiple outputs for this particular question. So let's try submitting this one. This has to work. Before submitting this one, let me copy paste the signature starter template. Just give me a second here. So let me come here. Just give me a second. So let me paste the signature starter template here. So this is fine. Let me copy this one entirely and let me come here and let me paste it. So this has to work. Let's see. Let me hit the submit button. So here you can clearly see the sample test cases. All the test cases got passed. Means the code got accepted, right? Means all the test cases got passed here. So our code works absolutely correct in this case. Our code works absolutely correct in this case, right? So yeah, I hope this works. Only thing is, you have to know the binary search. We have performed pure binary search here, right? So we went with a pure binary search. Only thing that you need to know, that we need to know for this question is binary search, how the binary search works, right? I hope you know the binary search, right? So I hope the solution part is completely clear along with the complexities and the approach, right? For now, this is it. Thanks for watching, guys.